my name is Gary Wish. I'm with DeLong's Incorporated. DeLong's is a steel bridge shop that's located in central Missouri. So we've worked for the Missouri DOT since long before I have been with the company, and I celebrated my 40-year anniversary last week. So um, I'm here to talk about what Missouri refers to as FARM. It's an acronym for Fixing Access to Rural Missouri, and it was a design build uh, project that MoDOT came up with and took proposals about a year ago and made an award. Let's see if I can get it. There we go. MoDOT had several goals with this project. They had a minimum of 30 with an ultimate goal of 40 bridges that they wanted to have repaired or replaced across rural northern Missouri. Several of these had load restrictions, a 5 or 10 ton limit, and that kept school buses and farm equipment off of some of these bridges, and they wanted to get that taken care of. And due to the load restrictions, they made some of the bridges, they changed the lanes and striping and made them single lane structures, and they wanted to get all that back to where they had a minimum of two 12-foot lanes on each structure. They had a budget of $26 million, and basically what they did for the contracting and consulting engineering industry, they said, we've got $26 million and tell us what you can do. So in real simple terms, they wanted to know how their criteria for determining the winning team was going to be: how many bridges can you repair or replace? How durable and long lasting will your bridges be? And because for many of the residents in these areas, and these are low traffic volume roads, but it's the only way into town. It's the only way into your school or your shopping district or whatever. So it's important to minimize the disruption to the traveling public. So Missouri came up with a scheme, and I know there's at least one or two MoDOT guys on the watching and listening. So gentlemen, I hope I don't mess this up. But they had a scheme where they awarded up to 100 points total. 40 points for getting the minimum requirement of 30 bridges built, some bonus points if you could get over 30 bridges, some points for quality and longevity, and then, as I had mentioned before, the disruption to the traffic was a big deal, so maintenance of traffic was important. 3 contractor engineer teams chose to bid on the job. Team 1 used all concrete structures. Team 2 used a mix of steel and concrete, and Team 3 used almost exclusively steel, and we'll get into a little bit more detail there. And they chose galvanized steel, and they, I don't know the details and how it all went down, but Team 3, who chose the galvanized steel, had the most points under bridge quality and longevity. So that certainly has to mean something. I show here a typical design plan that shows that the span lengths here are short, and this is typical of all the projects in all the bridges in this farm project. It shows as you can see across the top of your screen, a 31 foot, 45 foot, and 31 foot, and it calls it a continuous composite wide flange beam span. And these were actually designed simple for dead load and continuous for live load. And we'll get into a few more of those details here in just a minute. This is another page from the design plan, and my point here is to show the simplicity of the design. And this one is on about a 45-degree skew, but still just not very complicated at all. The details in the center show the shear stud spacing, so it is truly, in fact, a continuous for live load design. The detail in the lower left, which I'll try to blow up there a little bit, shows the channel diaphragm, and I'll have a picture or two from the job site. And once again, the engineer did a really nice job keeping this as simple as they possibly could. The lower right is a detail that shows the end condition at the intermediate piers. What they did here, and it worked out really well for us, they used an end plate instead of bearing stiffeners. So instead of two stiffeners, one on the near side and one on the far side, with a machine to bear finish on the bottom, they put an end plate on that can easily be done with a fillet weld. And then on the end of the end plate, at the bottom there, they've put in a 3-inch square bar that lengthwise for the bar in and out of the screen matches the width of the bottom flange. And we had not done anything like that going into this, but it's turned out to be a really simple and easy to fabricate design. This is page 1 of our shop drawing, and it almost exactly matches the design plan. We've added a few dimensions that were key to us. We've added some piece marks so the erector knows which piece to put where. We've added some general notes in the bottom left-hand corner and some typical clip and weld details, and we were ready to go. This is the first truck that's going out the door. It pulled out of our lot on I believe it was a Tuesday morning, about 10 o'clock in the morning. And that's the whole bridge. The entire bridge fit on one truck. This first structure was about 15 tons, and they range, it's one of the smaller ones, they range from in the low teens up to around 38 or 39 tons. So they won't all fit on a single truck, but this one did. And it pulled out about 10 in the morning, and I noticed it going out the door. So I called the contractor and I said, hey, I'd really like to come up and get some pictures of this being erected sometime in the next couple of days. Do you have a problem with that? And his response was, well, you better hurry up. And so I left my house about 6:30 the next morning, and it's about a 2-hour drive to the job site. And when I got up there, this is what I saw. On the right-hand side, you can see the crane that was just pulling off the pad that they had temporarily built in the creek there. So I got up to the job site less than 5 working hours or business hours after the truck had arrived on site, and I didn't get to see a single piece of steel being erected. All 12 of the wide flange beams and all 12 of the channel diaphragms were already in place when I got there. So it was fast and easy for us to fabricate, fast and easy for the contractor to erect. I have excuse me, just a couple pictures with some details. The goal here is just to show the simplicity of the channel diaphragm. By the way, that's an embedded end at the abutment. So there is no end diaphragm. And if I remember right, and I'm sorry I don't have a picture of it, but I believe that instead of sitting on a bearing, the beam the galvanized rolled beam rested on a little piece of channel that was attached to the top of the piling, if I remember right. Here again, a blown up detail of the channel to beam stiffener connection. That channel was, at least in our shop, was hardly touched by anybody. It runs through an automated drill line. The program comes directly from our shop drawing, and so the holes were drilled and the saw cut it with very little effort on our part. I show this to hopefully clarify the simple for dead and continuous for live design. You can see, and I hope you can see what my cursor's doing here. I'm trying to circle up where those 3-inch square edge blocks are, and those are welded to the end plate at the end of the stiffener, at the ends of the beams that bear on the intermediate piers, and that provides the load transfer across the compression flange. So and I don't know from the engineer standpoint how much weight they might have saved by going, instead of doing all simple span completely, by going to a simple for dead, continuous for live. But but obviously with this design winning out, they had some success with the method. So um, I show this picture, and I know I'm running a little bit short on time, but I show this picture for two reasons, and one is to repeat that Missouri was interested. They wanted to keep these bridges as maintenance free as they could, so they were going to award points for long-lasting and durable structure. And you can see there that even the piling at the intermediate piers is galvanized, as well as the superstructure that we provided. So that was important to the DOT and seemed to work out very well on this first bridge that was erected and the others that have come after it. And the other thing I wanted to show here is we all get caught up in, all of us in bridge design and construction and fabrication, we get all excited about major river crossings and major intersections, and that is a big deal. But I tell you, for the people who travel over these bridges, even though these traffic counts are in the several hundred per day, to these people to get to and from town, to get to and from their children's school, these are every bit as important as the major river crossings. And this, I'm on the east end of the bridge facing west as I take this picture, and you can't see any structures or anything else going on for about a half mile going up that hill. And if I turn around and look to the east, I have exactly the same thing going on. So they're out in the middle of nowhere, and they're easily forgotten, but they're very important to the residents in the area and the state that owns them.